Hey guys, so this is going to be a short little video, like I said in class, that's going to go along with question 3 and question 6 from the note worksheet from today, since we didn't have time to do those in class, just in case you wanted another example to look over and make sure you were answering correctly. So the first one says, Hawaii has been experiencing a 1.06% annual increase in their population. In the year 2005, the population was 1,211,537 people. So population is going to be our Y, and time since the year 2005 is going to be our year. So year since 2005. And we'll do P of T for this example, P for population, population of Hawaii. All right, so when we write our model, you're going to go through and set it up according to our formula. And I suggest you could try doing all these parts on your own and then just watch the video to make sure you did it correctly. So I'm not going to pause or anything for think time. I'm just going to go through the process. So we're going to have P of T equals the initial amount, or the initial amount of people, which is going to be 1,211,537 times 1 plus 0.0106. We have to divide that percentage by 100 or move the decimal 2 times to the left to the T. Okay. We're going to go one step further and actually combine the 1 plus our R to get our B value. So P of T is going to equal 1,211,537 people times 1.0106 to the T. So there's our model. We're then going to use it to predict how many people there will be in the year 2020. So we have to compare that to our starting year of 2005. So that's 15 years later, which we will input for T, since T is talking about time. P of T will equal our equation. Oh, there's the bell. Raised to the 15th power. And then we can just do that on the calculator in the correct order. So we're going to do the exponent first, and you should get 1.1713, etc., and multiply that by the 1 million number. And we're going to have a total of 1,419,140. I'm going to round up to 3. Since we're talking about people, it's not going to necessarily make sense to have a decimal value. So I am going to round that to a whole number. So it will round up to 43. Okay. And for part C, we're trying to figure out when will the population reach 2 million. So the 2 million is going to be subbed in for P of T. Make sure I have enough zeros there. Equals the rest of the equation. And we're going to go ahead and use our calculators to estimate. So we're going to go into our Y equals screen, type in our model. And then, of course, I wish I could show this to you guys actually on the calculator, but for some reason it's still not working. So I'm not going to be able to do that. Okay, I'm just finishing up typing it in my calculator right now. 0106. And if I go to my input-output table, I'm going to look for 2 million in the Y column. You're going to notice that the Y column is going to have that E there for scientific notation. So I suggest you move your cursor over to the right so you can actually see what the number is down at the bottom. So I'm going to keep scrolling, and I'm going to get there during year 47. So year 47. It's 1,988,673, and by year 48, we are just over 2 million. It's 2,009,753. So what happens during the 47th year? And we're comparing that to the year 2005. So if we add those together, we're going to go ahead and get 2,052. That's the year the population will reach 2 million during that year. Now, if you guys wanted to flip over to the back, I'll go through number 6 with you. Okay, number 6 says, the house down the street has termites in their porch. The exterminator estimated that there's about 80,000 termites eating at that porch. And the treatment he's going to put on the wood is going to kill around 40% of those termites every day. So we're going to start off writing our model, but also make sure we know what our variables are representing. T in this case is not years. We're talking about days in this particular example. And F of T is going to be the number of termites. So our model, F of T, equals, so there's initially 800,000 termites. They are dying from the treatment, so this is a decay problem. It's going to be 1 minus our rate. 40% as a decimal is 0.4 to the T. And then, like I said in class today, we have to combine the 1 minus R to get our B value. So our model will be F of T equals 800,000 times 0.6 to the T. And we're going to figure out, will those termites be extinct in 3 weeks? We have a different unit here, talking about weeks compared to days. So 3 weeks, if I multiply 3 times 7, is 21 days. So let's go ahead and see how many termites there are in 21 days, if it does in fact kill 40% each day. And hopefully the actual treatments are a little more realistic than that, and that the termites are exterminated immediately. We do not want those termites lingering around. But if we're using this particular model, let's solve that. F of T equals 800,000 times 0.6 to the 21st. Just type that into the calculator, 0.6 to the 21st power, and then multiply by 800,000. And we're going to get approximately, and I'm rounding up here, since we're talking about a number of termites, 17.5, or round up to 18 termites. Therefore, they are not extinct yet, but close. All right, so that is the 2 examples that we weren't able to do in class. If you decided to watch this and just see some additional examples. And good luck on your homework. You guys have 2 to try on your own, and I'll see you guys tomorrow. Have a good night.